The initial reaction that I had is the same reaction that many of my colleagues here at Stanford and elsewhere have had when I've shown them, is that, wow, what is this? The question is important enough in at least two ways. The primary reason is that there's a lot of claims about specimens and claims about aliens. And of course, there's a lot of ridicule associated with that. So one of the best things that we should be doing, of course, then is bringing the best scientific techniques to bear. The techniques are available, the techniques are cheap, the answers are nearly absolute, so let's do it. And it's so exciting because it's not just... In setting up for this, I'm going to be giving Steve not only the tubes that this should be going into, but I'm also going to be sending across the microscope that I feel they should be using to do the analysis with. Before we even get started with some of the analysis, I think it's going to be important to rule out some of the obvious critiques that could come up. And one of those critiques is that this is a syndrome or a mutation. This is a bone dysplasia. And luckily, here at Stanford, we happen to have literally the world's expert, the man who wrote the book on bone dysplasias and syndromes, a gentleman by the name of Dr. Ralph Lockman, who has kindly agreed to look at the specimen, both the pictures as well as the CT scans and the x-rays, to help determine whether or not it's anything that he's ever seen before. I think that a dozen or even 15 years ago, answering the question of what is this would really not have been possible because the kinds of technologies were not available as are available today. But really the DNA tells the story. And because we have the computational techniques, that allows us to determine in very short order whether in fact this is human. So this will be basically an absolute level of proof as to what this actually is. Right, well, if somebody made it, they have a future in microsurgery because they were smart enough then to put in these millimeter-wide bone holes where the arteries go in to feed the bone marrow. And so now the challenge is to prove what it is, right? My interest, frankly, is to disprove that it's anything unusual or anything paranormal. I would like to prove that this is human. I would like to prove that this is just an interesting mutation. But obviously, if you leave your mind open, or I should say, if you leave your mind closed to alternatives, you'll never see what those alternatives might actually be. In every situation with scientists, your reputation's at stake. You know, I have every expectation that even doing this is going to lead to some ribbing from some of my colleagues, right? But I think that that's perfectly acceptable because at the end of the day, who's going to validate these things? If someone isn't willing to step forward and do it right, then you're going to have it sitting out there forever, hanging in limbo, right? I mean, if you let other people and their opinions stop you from believing what you know to be true, then all you're doing is stopping the possibility of progress.
That of a human.
One of the first things that Dr. Lockman immediately remarked upon was the shape of the head and the skull. It was not something that he is accustomed to seeing, and it was quite interesting and in some ways exciting that the associated features that you would expect from a syndrome of that nature were not found. This specimen does not fall under any known, to me, class of disorders or syndromes. In many respects, the proportions of the spine and extremities are normal. The major abnormalities appear to be, one, the size of the specimen, mid-face hypoplasia and underdevelopment of the jaw, and that the specimen has only 10 ribs. Humans normally have 12, rarely 11. One of the most remarkable aspects of this is when we came down to study the actual bone density, one of the features of fetuses that specialists looks at is the so-called growth plates of the epiphyseal joint, say, of the knees. The shock, I think, and the surprise was, and the absolute certainty that Dr. Lockman had was that this specimen is between the age of 6 to 8 years old. The shock was that this specimen was clearly not fetal. How do you explain how something 6 inches tall survived to any length of time that would allow for it to survive 100 or 1,000 years ago?
And what amazes me is the media.
Muy pequeño de la costilla, pero no.
It's got too much tissue on it. They actually want a piece of the bone from at least like a 0.5 of a millimeter in.
Como medio milímetro de.
We took material from inside the cranium, also 2 clippings of the anterior front ribs of this being. And we were able to see under the dissecting microscope that, in fact, it did have bone marrow in them, so that meant there should be some good genetic material in there.
It was really nerve-wracking. Imagine, 2 big guys here trying to operate on this 13-centimeter long beam. But we did it.
The DNA analysis is being done by some of the world's best, but even the world's best need to be cross-checked, which is why I'm doing the 3 different facilities. So I actually ran 4 samples. I ran a sample of my own blood. It was a very small amount, just 100 microliters. I ran 2 blanks, things that just had water in them, because that would be essentially a contamination control. And then, of course, the sample itself. And really, the all-important first result was whether or not there was, in fact, any DNA, which was isolated. And the actual shock for me was when I got the amount of DNA out of this sample. It was way above what I had originally expected. What you have on the left here is a so-called DNA ladder. This is a size standard. This one on the end is, in fact, my DNA, and it has an expected size distribution as well as some banding. And validating the original measurement is this analysis that basically shows that we have a nice distribution for the sample's DNA.
When we physicists look for alien.
So this is an example of how the analysis is done using what's called a genome browser. And it's more or less a schematic representation of the chromosomes and at a very high level of resolution. So the sequence that we got from the mitochondria tells us with extremely high confidence that the mother was an indigenous Indian from the Chilean area, and the haplotype is called B2A. Now, the other thing that immediately fell out of the analysis is that it's male. It has so-called Y chromosome material. In fact, it's got a full Y chromosome. It probably died in the last century, if I were to make a guess. I can say with absolute certainty that it is not a monkey, right? It is human, or as close to human, closer to human than chimpanzees would be. But when you count up the number of mutations that we're observing, what we're seeing is more than what we would expect to be caused by simple cell division. When the sequencer is creating or making these reads, it's doing it more or less at random. So what does the computer program do that people have written and designed? It takes every one of the little sequences and tries to match it against the known. And then anything that doesn't match, it puts in a little side file and says this is unknown. At a certain point, when enough knowns are matched, I can feel comfortable saying, this is human, right? But if I'm not careful and I don't pay attention to what's in the garbage can, right, what the computer program is throwing away, I could literally be throwing the baby out with the bathwater. What we've done is we've scaled back and we're seeing several chromosomes and pieces of chromosomes across the top, which basically leaves us with a very strange conundrum, right? Here you've got this 6-inch tall, let's call it human, right? Because the DNA says that so far it's human, at least the way that we're looking at it. This gene, PCNT, which is known to be associated with primordial dwarfism, we don't have any mutations here. It lived to the age of 6 to 8. Obviously, it was breathing, it was eating, it was metabolizing, and it wasn't living in an environment where there was a lot of advanced medical attention that was given to it to allow it to live to that age. Calls into question how big the thing might have been when it was born. So genetically, you might explain that by saying that there's some advanced aging mutation, something that caused the bone to age anomalously quickly. A gene that's known to be associated with progeria, that also no changes there. So the next problem, of course, is the ribs and the number of ribs in the specimen. Only 10, whereas there are supposed to be 12. So there are no mutations which are specifically associated with that kind of phenomenon because it's rarely, if ever, seen. The digits are all correct. The hands are all correct. There are problems with the face. So there's a mid-face hypoplasia, and then there's the larger skull. So again, I think in summary, there are genes associated with any one or two of the anomalies that we see in the specimen, but there is no mutation which is known to accommodate or call for all of the mutations. Even with the things that we know could be assigned to one or more of the anomalies, we don't find them in the genetics of this specimen. That leaves open the question, what genetics is causing the anomalies that we are observing? So, although I entered this thinking DNA was the answer, it made me realize that in the context of the bigger biology questions, there are other levels of control that need to be understood and answered. The non-coding RNA, epigenetics, etc. And things that we probably haven't even thought of yet. So if I just look at, this is base pair 19,800,000 or so at this edge of the open region. I can go all the way over here, and now I'm at 21,000 or 22,000. So the answer is not finished, and it's not as easy as actually, frankly, I thought it was going to be at the beginning. So that's basically 2 million base pairs of DNA where nothing seems to sit. It's just like the way societies do things. They try to fit things in boxes. We have literally written a computer program that does exactly that, tries to fit it in the box. Doesn't seem very efficient, so on that basis, people would call it junk. But I think we now know that there's any of a number of other features of what DNA is doing in there. It is expressed. And so we need to be careful, obviously, that we don't let our instincts or the programs that we write to match our instincts make the decisions for us. No matter what, for me, this has been a fascinating, more than an exercise. As soon as I've collated this information into a form that other people can take advantage of and it's accepted for publication, I'm just going to put it out on the web. You know, I don't have the resources to study and follow down every single angle that this opens up. But, you know, maybe there is a listener out there who will be sufficiently intrigued by this to do the analyses themselves, and maybe they'll find something that I missed. Great. If additional samples or examples are seen of this, I'll be the first in line to want to sequence it, because then all bets are off. I want to say other things here, but I also don't want to open myself up for, you know, attack.